Hi, it's Mark here. I want to talk to you a little bit about continuity. So continuity is the ability of a material to allow electrical current to flow through it. And one of the ways you can test for continuity is using a little device like a multimeter. Now, there's lots of different multimeters on the markets and they've got lots of different settings, but this one has a particular setting that tests for continuity. It's that little symbol in there. And at the moment, you can see that it reads 1. Okay, what we want to do is try and change that number 1 and get it down to 0 as close as we can. Okay, so I'll give you an example. If I take something that's non-metallic and I put, like PVC, and I put that on there, okay, the reading stays as 1. It doesn't change. But if I take something that I know can conduct electricity, like copper for example, and I put it there and there, you'll notice that number starts to decrease and gets lower and lower and lower, okay, and gets down to 0.001. That's as low as it can go on this particular multimeter. Okay, so what should happen here on a pyramid? Well, if I connect that to that, you can see I've got continuity. That allows electrical current. But what if I connect that and that? In theory, if this is touching that, then that should drop as well. And you can see that it does. And if I come over here and I do that, you can see that drops as well. So in theory, if that's connected to that and that's connected to that, then I should be able to get a reading like that. So that tells me the copper pipe is connected, even though those connectors aren't actually made out of copper. Okay, it's the way I've designed those connectors. Now the same works for the capstone. Okay, now it's not critical that this has to conduct electrical current, okay? It's just I'm very precise about what I do and I like to show people how it can work. It can be a bit fiddly to try and get these to connect, so what I tend to do is if I'm not getting a reading there, what I'll do is I'll get a little block of wood, and I'll give you an example. I'll just tap that away a little bit, okay, and you'll notice I'm still getting a reading there. That's good. That's a good connection. So what I'll do is I'll disconnect it a little bit and I'll move that away, and you'll notice now I'm not getting a reading. But if I come around here and I tap that back into place, okay, use that block of wood. Don't put a hammer directly onto there because you could damage your connector. We don't want that to happen. Okay, I've got a reading there. I still haven't got a reading. Oh, there, I've got a reading. See that? That's connected now. So that's a good sign. If I come over here, I'm not getting a reading. So again, that has to be tapped as well. Okay. So it's a little bit of fiddling around, but eventually when you get a reading there and a reading there, you'll know you've got it. Okay. So as I said, if you want to go to the trouble of doing that, you can, but you'll have to go around and do that to all 4 corners and the capstones. So it's a very precise, delicate calibration. Again, for me, it's all about the geometry, and it's all about using phi and using those measurements to create that geometry that you can see in this pyramid here. So while continuity is fun to play with, it's not an essential ingredient of any of our pyramids. So have fun if you ever decide to play around and see what you can do. And let us know how you go. Bye for now.